Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held in the month of March 2025 for Assam State. It is a rescheduled examination conducted for Assam State. In this video, we discuss the solution of a problem from the section Complex Analysis, and the problem is related to Cauchy's theorem and Cauchy's integral formula, and the question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks, and the question ID is 706562. This question is suitable for all these examinations. Right. The given question is, let P of Z is equal to A0 plus A1Z plus etc. plus AN Z power N be a polynomial of degree greater than or equal to 3. Suppose that P at 0 is 0 and P prime at 0 is not equal to 0. Let F be a map from the non-zero complex numbers to the set of complex numbers C defined by F of Z is equal to P of Z by Z square. Which of the following statements are true? We are given 4 options. Option 1, F has a removable singularity at Z is equal to 0. Option 2, F has a simple pole at Z is equal to 0. Option 3, integral taken round C, P of Z by Z with respect to Z is equal to 0, where C is any counterclockwise oriented smooth closed curve in C. Option 4, integral taken round gamma of F of Z with respect to Z is 2 pi I A1, where gamma is the set of all Z belongs to C such that mod Z is equal to 2025 is a counterclockwise oriented circle. Right. Let's now discuss the solution of the problem in detail. We have a polynomial P of Z is equal to A0 plus A1Z plus etc. plus AN Z power N of degree greater than or equal to 3. Given P of 0 is equal to 0, this implies 0 is equal to P of 0, and in P of Z, put Z is equal to 0, you will get A0. Thus, we get A0 is equal to 0. We take P of Z, differentiate with respect to Z, then it will be P prime Z is equal to A1 plus 2A2Z plus so on and so forth plus NANZ to the power of N minus 1. And it is given P prime at 0 is not equal to 0. So in P prime Z, put Z is equal to 0. This implies 0 not equal to P prime 0 is equal to A1. Thus means A1 not equal to 0. Thus we have P of Z will be A1Z plus A2Z square plus so on and so forth plus ANZ power N, where A1 not equal to 0. Agreed. Now, we are given a map F from the set of non-zero complex numbers to C defined by f of z is equal to p of z by z square. That is, f of z is equal to, write p of z by z square. Then it will be a1 z by z square, that is a1 by z, a2 z square by z, a2 z square by z square is a2, a3 z cube by z square, a3z plus so on and so forth, plus an z to the power of n minus 2. Now, let's now answer the options. Option 1, f has a removable singularity at z is equal to 0, and option 2, f has a simple pole at z is equal to 0. If you see f of z, a1 by z plus a2 plus a3z plus an z to the power of n minus 2, it's very clear that z is equal to 0 is a simple pole. It's very clear. But anyway, now limit z tends to 0 of fz, let us see what it is. Then limit z tends to 0 of a1 by z plus a2 plus a3z plus so on and so forth, an z to the power of n minus 2. It will be infinity. It will tell you, this will tell you z is equal to 0 is a singularity. But it is not a removable singularity. Had it been a removable singularity, limit z tends to 0 of fz would have existed as a finite number, as a finite quantity. But it is tending to infinity, therefore z is equal to 0 is definitely a singularity, but it is not a removable singularity. Right, option 1 is not true. Now, further, limit z tends to 0 of z into fz, z means z minus 0, z into fz is limit z tends to 0 of z times a1 by z plus a2 plus a3z plus so on and so forth plus an z to the power of n minus 2. Then z into a1 by z is a1 plus a2z plus a3z square plus an z to the power of n minus 1. Take the limit, then it will be a1 exists as finitely. Limit z tends to 0 of f of z is infinity, and limit z tends to 0 z times f of z is a1 exists finitely. This will tell you that z is equal to 0 is a simple pole of f of z. Systematically, this is the procedure of showing this as a simple pole. But however, on seeing this one, you can very easily conclude that z is equal to 0 is a simple pole. Anyway, option 2 is true. Right, we continue in the next slide. Let's take the option 3. Integral taken round C, p of z by z with respect to z is 0, where C is any counterclockwise means anti-clockwise, that means positively oriented, smooth closed curve, is a closed curve and it's smooth in C. Now let C be any, not one, is any counterclockwise oriented smooth closed curve in C. Then the integral taken round C, pz by z will be, integral taken round C, pz is a1z plus a2z square plus so on and so forth, an z to the power of n by z. And this will be integral taken round C, then this will become a1 plus a2z plus so on and so forth, an z to the power of n minus 1 with respect to z. It's a polynomial. Every polynomial is analytic everywhere. Therefore, it's an entire function. And C is any counterclockwise oriented smooth closed curve, any one. That is why it's an analytic function everywhere. And therefore, applying Cauchy's theorem, integral taken round C will be 0. So option 3 is true. Go for option 4. Integral taken around gamma f of z dz is equal to 2 pi I a1, where gamma is a circle with the center 0 and a radius 2025. It's a counterclockwise oriented circle. Right. Integral taken round gamma f of z dz is equal to integral taken round gamma f of z. F of z is a1 by z plus a2 plus a3z plus anz to the power of n minus 2 dz. So this will be integral of the sum is equal to sum of their integrals. So a1 times integral dz by z plus integral taken round gamma a2 plus a3z plus so on and so forth an z to the power of n minus 2 dz. And this will be equal to a1 integral taken round gamma dz by z. Why? This becomes 0. Why? This is a polynomial. Polynomial, it is analytic everywhere. The integral taken round gamma will be 0 by Cauchy's theorem. Now you are left with a1 integral taken round gamma dz by z. Apply and gamma contains 0 as its center. So 0 is an interior point to gamma. So apply your Cauchy's integral formula. Then it will be a1 into 2 pi I by Cauchy's integral formula. So thus you get option 4 is also true. So summarizing all the options, the answer to this question is options 2, 3 and 4. And that is the detailed discussion of the solution of this problem. And in this problem, the examiner wanted to test you when a singularity is a removable singularity, when a singularity is a pole, and what is Cauchy's theorem and what is Cauchy's integral formula. He wanted to test these things. That is why he has designed such a question. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, we will definitely meet you all once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.